Hi guys, welcome to EduUdr. This is Prajith. Today we will see how to fix a suitable resistor for an LED circuit. Here we have an LED circuit on the right. We have a green LED with a maximum forward current of 25 milliampere and we need to find the resistor to safeguard the LED when we connect the LED to a 9 volt supply. So different colors of LEDs have different maximum voltage. So I will explain. To get different colors, we are using different combination of semiconductors inside these LEDs. So each color of LED is having a particular and unique forward voltage. Say red is having 1.7 volt, yellow is having 2.1 volt, green is having 2.2 volt. So in the above figure, we were using a green LED. So the maximum forward voltage is 2.2 volt. Now there is the equation to find the resistance. The resistance, that is this resistance, R is equal to Vs minus VLED by ILED, where Vs is the source voltage, VLED is the maximum forward voltage of the LED, and ILED is the optimum LED current. So we should substitute these values in this equation and we'll get like this 272 ohm. When optimum forward current of LED is unknown. So in the first problem we were given the current. So in this problem we are not given the current. Suppose we have a 0.5 watt white LED needed to be connected to a 6 volt supply. Here optimum current ILED is unknown, so we need to find it. We have the color of LED as white. Hence from the chart voltage of LED is equal to 3.2 volt. Also we are given the power P is equal to 0.5 watt. So we can use the power equation P equal to VI. So 0.5 is the power given, so 0.5 equal to 3.2 into I, where I is the unknown current. So we can find the unknown current as dividing 0.5 by 3.2. Now we get the current as 156 milliampere. Now we have value of optimum forward current. So we have to put this value in the previous equation for resistance. Put the value of current ILED in this equation. So 6 minus 3.2. 6 is the voltage source and 3.2 is the forward voltage of the LED, white LED, and this is the milliampere converted to ampere. So 10 raised to minus 3. Now we will get 80 ohm resistance. That is the required resistance. So a 0.5 watt white LED needs 18 ohm resistance when connected to a 6 volt supply. Suitable resistor for LED combination. So let's see how to design resistance for combination of connected LEDs. The concept we are going to see is also useful with other electric loads. What consumes the output power is a load. Here we have two LEDs as loads. So this is series connected LEDs. The LEDs are the load. In series connection of LED or any other load, we have same current through them while different voltage drops. Let me explain. Series connected load. So let us take the loads as resistors. Here they are connected in series. As you can see, the resistance R1 and R2 and R3 and R4 are connected one after the other. So these are connected in series. So current through them is total voltage supplied divided by equivalent resistance. So the total voltage supplied is this, that is V. So that V divided by the equivalent resistance of these resistors gives the current through them. So this is the current. So the total resistance or the equivalent resistance can be found by adding R1 plus R2 plus R3 plus R4. That is, in a series connected load, we can find the total resistance by adding the given resistors. Also, voltage, that is the supplied voltage, is equal to V1 plus V2 plus V3 plus V4. That is, these V1 to V4 are the voltage across these resistors R1, R2 and etc. until R4 respectively. So the total voltage is the sum of these voltage drops. these voltage drops here. Parallel connected load. Here, resistors are connected parallel to one another. So as you can see in the figure, the resistor R1 is connected parallel to R2, connected parallel to R3, connected parallel to R4. So voltage across resistors R1, R2, R3, R4 are same, and the voltage is itself the voltage supplied. So as you can see, here we are supplying the voltage V, and it is going to one terminal here. The positive is going to this terminal and negative is going to this terminal. So four loads draws the power from these 2 points. So the voltage across these are equal, and that is the supplied voltage. The current I equal to I1 plus I2 plus I3 plus I4. So the current is different. So from this junction, the current flowing will be distributed to 4 routes, and the current value of these branches are all dependent on the resistance there. So also we can find the current by dividing the voltage with the equivalent resistance. So let's see how to find the equivalent resistance in a parallel connected network. So in parallel connection, the reciprocal of equivalent resistance is equal to the sum of reciprocal of each resistors. So here the reciprocal of first resistor plus the reciprocal of second resistor, etc., plus the reciprocal of last resistor gives the reciprocal of equivalent resistance. So once again, we can get the equivalent resistance by taking the reciprocal of these ordered values, like 1 divided by these. Okay. Also, as we said, the voltage V is equal to the voltage across each resistance VR1, VR2, VR3, VR4. So required resistors for series connected LED. So here we have a series connected LED. So two yellow LEDs. So as we know from the chart, the yellow LEDs have 2.1 volt forward voltage and 20 milliampere current. So these LEDs have 20 milliampere forward current. Both of them are yellow LEDs. And we have the supply voltage of 9 volt. So we need to find the resistance. The equation for finding the resistance is here V minus VL1 plus VL2 by ILED. So this V is the voltage supplied and VL1 is the voltage drop across first LED and VL2 is the voltage drop across second LED. So the V is 9 volt, 9 minus. So here we are using same LED, so 2.1 volt same. So 2.1 plus 2.1. So 9 minus 2.1 divided by 20 milliampere, that is the current. So 20 into 10 raised to minus 3. So when calculating that, we will get 240 ohms. So these two yellow LEDs of 20 milliampere needs 240 ohm resistance to be connected to a 9 volt source. Required resistor for series connected load LED. So here we have a yellow LED and another blue LED. So both of them are having 20 milliampere current. But forward voltage for yellow is 2.1 volt, while that of blue LED is 3.2 volt. So here is the equation to find the resistance. So put the values in the equation, we will get 185 ohm. So we can use different colored LEDs, that is LEDs having different forward voltage in series connection, but we should use the 20 milliampere, because if we are having a 20 milliampere and another one of 30 milliampere, when the resistance is adjusted for 20 milliampere, the 30 milliampere LED will not glow well, and if we adjust the resistor or reduce the value of the resistor to increase the brightness of the 30 milliampere LED, what happens is that the other one will burn off due to high current. So it is advised to use LEDs with same current rating in series connection. Required resistance for parallel connected LEDs. So in the figure we have two parallel connected LEDs. One is 20 milliampere and other is 30 milliampere, but both of them are yellow LEDs. So they have to be connected to a 9-volt source. So the equation to find the resistance is R equal to V minus VL by ILED. So this V is the voltage supplied, that is 9 volt, and VL is the LED voltage. So we can use same LEDs with different power rating. So here we have a 20 milliampere and other we have a 30 milliampere. So the total LED current is sum of these two, that is 20 plus 30, 50 milliampere. So substitute these, the 9 volt, the voltage drop across LED, that is 2.1 volt, and the current 20 plus 30, that is 50 milliampere. We will get 138 ohm. That is how we should find the resistance. Here it is advised to use LEDs with the same forward voltage rating in parallel connection. That is because if we are using two colored LEDs, say 2.1 volt LED and another with 3.2 volt LED, what happens is that this resistance will be able to supply a particular voltage, and if we are arranging the resistor for glowing the lower powered LED, that means low voltage LED, the high voltage LED will not glow. So if we adjust the resistance for glowing the high voltage LED, the low voltage LED will burn off. So it is advised to use LEDs with same forward voltage rating in parallel connection. Thank you for watching EduUdr. If you haven't subscribed to our channel, please subscribe and like and share with your friends.